From the north side of the San Francisco Bay to Singapore, welcome to Urban X Real Talk Fitness Radio with your host, business owner, lecturer, author, master trainer, Tiaja. With over 30 years of experience in the health and fitness industry, he will challenge the fitness between your ears. So prepare your mind, body, and soul for the revolution of self-care, the evolution of fit, with real talk about real people, real health, real fitness, and the real deal behind our present illness culture. Real talk every time, all the time. Get weekly insights on how to shift your thinking, emoting, eating, training, hydrating, goal setting, and resting for you, the everyday athlete. You can cheat your fitness, but you can't steal your health flow. It's Tuesday, 9 a.m. Let's flow.
Welcome to Urban X Real Talk Fitness Radio, where we challenge the fitness between your ears. I'm your host, Tiaja. For much of its history, the medical establishment has been fighting the wrong battle when it comes to cancer. The conventional approaches, chemotherapy, radiation, and surgery, have done little or nothing to abate the incidence of cancer. Not only do they use the wrong weapons, they are fighting the wrong enemy. The cancer campaigns, which attract hundreds of billions of dollars every year, waste its enormous resources by targeting the disease and not the cause, boasting a cure for cancer does zilch without the seriousness and clarity of purpose to combat its cause. Now, conceived in explicitly military terms, the effort has focused on defeating an enemy by detecting and treating and stopping the proliferation of the disease, but overlooked and suppressed are any considerations of how our bodies successfully kill cancer hundreds, if not thousands of times within our lifetime. The result is appalling, over 10 million preventable deaths over the past 30 years. But the most disturbing aspect of it all is the fact that this is no accident. The economic sweepstakes is treating cancer rather than curing it, but once in a while, a new approach is leaked to the masses. It never comes highly heralded with major news coverage because those who profit off of illness would rather keep the cancer status quo the way it is. Thankfully, there are men and women like Dr. Lin who not only have taken the Hippocratic oath to quote-unquote do no harm, but they have gone one step further. They have made it their life's work to find the body's own cure to cancer. Today will be just another day unless you decide that it won't be. It is Tuesday. Let's flow.
Can I get a show of hands of how many of you in the audience have had a friend or loved one been affected by cancer, afflicted with cancer? So look around, right? A lot of people. And I'm going to ask this, and sometimes there are a lot of people, any people here has struggled with cancer themselves or a cancer survivor in the audience? Wow, give those people a round of applause. So this is my friend. The jolly giant in this middle is my friend Chris. We went to college together, and he's one of those good guys you can always go to. He'll cheer you up, will help you, anything that you want. So I got a call from Chris, I think about 4 years after we graduated. He wasn't his sort of jolly self. Chris had a sort of a hesitation in his voice. And you know where this is going. Chris said those 3 words that you would never want to hear. I have cancer. So when I heard those words, I was sort of in shock. Didn't know what to do. And I think for many of you who sort of experienced this, you just sort of like, let's try to sort of figure it out. So us friends with Chris and his family walked with him as he valiantly fought this cancer for about 4 years, going through chemotherapy, going through stem cell transplant, and unfortunately, about 4 years later, he passed away at the young age of 27. And that had a big effect on me. And in addition, I've had an aunt and uncle, many family members been affected by cancer. So knowing that this is such a big problem, I actually dedicated my life to cancer research. I've trained and been lucky to train in some of the world's top universities, including here in Baltimore. I spent 10 years here at Johns Hopkins getting my medical and graduate training, MD, PhD. I was in St. Louis, Washington city there. And currently, I do some work with the National Cancer Institute and helping them build their cancer, build their clinical genomics program in the Cancer Center. And the good news about cancer is that I'm bringing you news from the front that we are starting to win the war on cancer. So today, from the front lines, I'm going to tell you some of the things that excite me the most, that makes me wake up in the morning, of some of the latest developments in cancer research that hopefully will give you hope as you sort of think about, hear about this sort of horrible disease. So 5 things I want to highlight. The first one is cracking the code. For the first time in human history, we now really know what is the background in terms of the genetics of cancer. In the year 2000, a huge milestone as humanity, we were able to crack the human genome code for the first time. And subsequent to that, led by the researcher Bert Vogelstein here at Johns Hopkins, who I had the privilege of being on his team and him being our mentor, is worked tirelessly to take that code of the human genome and apply it to crack the genome of cancer. Working with him and with other colleagues, we sort of, being able to see how do we sequence every single gene in cancer, compare it to normal cells, figure out the DNA differences between them, and truly see what is the genetic face of this disease that we're trying to fight. And after sort of 2 years, we were able to do our initial searches, and our initial results that we published in 2006 is the first genomic landscape of cancer. This is one picture of cancer. If you look at if every line was sort of the genes, the mountains is where there's genes mutated at a very, very high frequency within this specific cancer, colorectal cancer. And the thing that we saw is that cancer actually is very, very different. Everybody's cancer is different. So thus, we need to be able to figure out a specific way to be able to target those cancers. You might have heard words such as personalized medicine or individualized medicine. And this is the future of us being able to fight this disease. So for the first time now, initially we did it with colorectal and breast cancer, then we mapped the cancer genome of pancreatic cancer and a brain cancer called glioblastoma, and we now have a global view of what's going on in terms of the genetics. I like to sort of see this as, imagine Christopher Columbus was sort of trying to sail, and somebody gave him a satellite map of North America, right? Instead of like bumbling in the dark, not knowing where to go, now he knows exactly where to go. And that is what cancer researchers now have. Billions of dollars have now been spent sequencing all the different types of cancer, hundreds of cancers in the US and in the world, and now we really have the genetic face of cancer. And sequencing technology has really been improving tremendously as well. What took us 2 or 3 years to do can now be done in a week in machines, half the size. And what's really exciting is there's machines now the size of a USB drive that's able to sequence DNA in real time. That's just coming out of the labs. So this is really exciting. Now, for the first time, we know the face of cancer, and we know what's sort of been able to cause it. And researchers are even able to detect these mutant DNA in the blood before it even grows, before you can even see it on imaging. So be able to treat cancer before it even starts, prevention, this is how one of the most exciting things that we'll be able to beat this disease. The second thing is what I call cancer snipers. Traditional cancer therapy has been really just sort of a carpet bombing and poisons. Some of you may know that initial cancer therapies was based on mustard gas. They looked at results of mustard gas, and there was differential sort of cell death, and they decided to use that as cancer chemotherapy. And that's not the way to do it, right? And that's why what it does is it targets cells that are fastly dividing, which cancer cells do more than others, but it hurts the other cells that are also fastly dividing, like our hair cells, our GI cells. So then you have these effects of, what you see of cancer patients losing their hair, having nausea, vomiting. That's an effect of the drug and not of the cancer. So how can we create drugs that's able to attack the cancer and not the body? And that is sort of the focus of sort of cancer chemotherapy research for the last sort of decade or so. So here's one little patient here. She was diagnosed with a disease like leukemia called CML at the age of 6. And normally, before any type of treatment, this is actually almost a death sentence. And her disease here, you see, is just really ugly. These leukemia cells, they just sort of grew out of control. And so for her, this research was done at it was done at Oregon Health Sciences University. They were able to figure out, and there's a unique signature to this type of cancer. It's called the Philadelphia chromosome. The details are less important, but basically we know exactly what's going on. There's a part of chromosome 9, chromosome 22, there's a switcheroo. It creates a new protein that's only present in the cancer cells. So knowing that, we can create drugs that attack this specific Philadelphia chromosome because this type of protein marker is only available, present in the cancers. So this drug was one of the most exciting things that came out sort of a while ago, and it was on the feature of sort of Time magazine, this drug called Gleevec. And the amazing thing is she is not only doing well, she's now going to college, going to be a nurse. So this is not just for leukemia, also, for example, for lung cancer. We have many targeted therapies for that. So if you have lung cancer, your genome can be now sequenced to figure out what's the genetic profile of your lung cancer, and we can be able to give specific drugs to be able to target that. So for example, if you're like the patient here, Molly, have a mutation in a gene called EGFR, there's a special drug just for her to be able to do that. Or if you're like this patient here, Liz, who has another mutation in a gene called ALK, there's a special drug just for that. Again, less side effects and more effective killing these cancer cells. And these cancer snipers get me even more excited than American snipers. The third area is what I call activating natural cures. And when you hear natural cures, you're thinking, oh, Jimmy, are you telling me to eat more vegetables with antioxidants? No, I'm telling you things are much, much cooler than that. In your body, you have cancer killers, which is your immune system. Cancer happens all the time in your body, and your immune system normally gets rid of it. And what happens in some cancers, so they're able to, what's called immune checkpoint. They turn off that immune system. So if you see sort of picture here on the right, there's the immune system actually killing the cancer. You can see it shrink it. On the other side, it is not shrinking because in that pathway, cancer is the immune system didn't turn off. There's genes called CTLA4, there's PD-1. This is an area of very active research. So if you're able to then turn off these inhibitors, basically turning on the immune system so it attacks these cancer cells, you're able to leverage this amazing natural cancer cure inside your body. And this is exactly what's been going on. Whether it's drugs against CTLA4, PD-1, there's so many, many companies working on these drugs now. And here's one example of what it's like. This is for melanoma. If you see at the very right, there's tumor everywhere. And as they give drug, the tumor literally melts away all over the body. And for the first time now, melanoma is being able to treat it. And it's a cure. It's not you live a little bit longer, it's a cure. This is an area of great excitement for scientists being able to use this method. And this is one doctor here, Dr. Anthony Ribas at UCLA, one of the pioneers of this research, and Tom Stutz here, who has been cured of his melanoma from this special immune checkpoint inhibitor. Again, very, very amazing, exciting stuff. In addition to that, what if your immune system needs a little bit of help? What I call supercharging your body. And so sometimes your immune system may not recognize this. And this is one patient. Another patient, this is little Emma. She actually ended up fighting 3 cancers. She had a cancer, they fought it, and it went away, then it came back. And ultimately, by the 3rd time it came back, they're like, you know what, we tried everything. Let's try this new way of doing it. So what they did with little Emma is that they took cells out of her body, the immune cells, the T cells, and basically trained it, gave it special instructions so that it can recognize cancer cells that it's not already doing. And this is what it looks like on the cell membrane. There are special receptors that are able to detect. This is called chimeric antigen receptor. So it's able to train your immune system to be able to attack those cancer cells. And look at this. 1 year free. 2 years free. And again, this is a cure, right? It now teaches your immune system to be able to recognize it, so if it comes back, your body automatically is able to fight that cancer. And lastly, not only can you use your own body, we can add extra stuff to be able to do that. And other researchers are being able to, what they do, they genetic engineer viruses and bacteria to be able to fight cancer, right? It sounds very, very cool. But don't think zombie apocalypse. We're aware of that. We're making sure that doesn't happen. But viruses and bacteria is very cool to cure cancer. So this is one, the measles virus, right? And we have vaccines in our bodies to be able to do that. This is one patient, Stacy. She has a cancer called multiple myeloma. This is her being treated at the Mayo Clinic with this genetic engineered measles virus. And you sort of get the picture by now. She's going to get cured of cancer. So Stacey is now cured of cancer with a special, and she's one of the first. These are what's called oncolytic viruses. Viruses is able to burst open just the cancer cell and not the rest of the cell. We have researchers. One of my friends at Autodesk is designing synthetic viruses, Andrew Hessel, there, to be able to custom 3D print special viruses for different cancers as they come. And it would be really, really cool once you be able to do that. Not only viruses, but also bacteria. This is a bacteria called C. novi. It's a sort of a flesh-eating bacteria in your feces, in the dirt, and normally really, really bad, right? But what's been done, actually, again, here at Hopkins, part of the lab that I worked on, is able to sort of genetic engineer that to take away the bad parts, right? But take advantage of the good parts. So this bacteria is able to grow only in areas without oxygen. So cancer grows out of control, and what it needs is to recruit blood vessels, what's called angiogenesis, so that it has oxygen. If without oxygen, it just dies, right? But then it's usually low oxygen content, and that's where the bacteria you put in, it'll grow and it'll eat away the cancer. And this is really cool to be able to take advantage of the special characteristic of that bacteria. So part of sort of our work, part of my work too, we sequence this bacteria and be able to really understand how this does and start actually treating it, doing some early clinical trials in humans and in dogs. And it's still very early, but I wish I could show you another cute little girl being cured, but I can show you a cute little dog. Dogs are now being cured of cancer, and hopefully we'll be able to cure humans of cancer as well using these bacteria, engineered bacteria. That's only 5 things. There are many, many more. Let me just sort of go quickly. There's special dyes that you can look at cancer so that in surgery you can cut out the cancer and not cut out the other parts. There's robotics now for surgeons. They can use robots to be able to do surgery. And ones that even if you've seen this movie, Ender's Game, this is actually a real robot that they took in the movie in the future. This is the Raven 4. It's being developed on the West Coast. So these open source robots be able to do surgery. And what's good is, you train them once, you don't have to train them again, right? Surgeons, as they get more experience, get better, these robots can just quickly become better than people. This is still very, very early. There's even ways to use sort of proton therapy to be able to do it. And there's just so much more that's really, really exciting. Just last year alone, 180,000 papers were published on cancer research. And this is the golden age of cancer, and this is why I wake up in the morning just really, really excited about the future of us beating this disease. We put together small teams. So some friends and I, we have actually a small consultancy that we're able to help individual patients be able to derive cures and create strategies. And we're seeing some really, really amazing results. And it's our hope and our dream that in our lifetimes, then cancer will be no longer a disease that causes fear, but will be one of those that you're like, oh, those 3 words, I have cancer, will be like, oh, okay then, take a couple of days off and come back on Monday. That is my dream. So for those who've had family and friends who fought cancer, for especially those cancer survivors or ones fighting cancer now, you are heroes. And all that we do, all the fighting, is for you. Thank you very much.
Now here are my 2 cents, and feel free to keep the change. The idea of targeting sequenced genes to eradicate cancer makes sense. Finally, the bioindividuality of the patient is being considered. So targeting cancer with what Dr. Lin affectionately calls cancer snipers is medically speaking brilliant. As you know, I'm not a fan of using synthetic drugs to combat disease. However, targeting a specific disease based on one's individual DNA is a more humane and frankly intelligent approach to treating diseases like cancer. To me, treating cancer humanely and intelligently is a moral imperative. Anything less is inhumane and simply wrong. Dr. King once said that cowardice asks the question, is it safe? Expediency asks the question, is it politic? And vanity comes along and asks the question, is it popular? But conscience asks the question, is it right? And there comes a time when one must take a position that is neither safe, nor politic, nor popular, but he must do it because conscience tells him it is right. Dear friends, I wish above all things that you prosper just as your soul prospers. You've been listening to Urban X Real Talk Fitness Radio with your host Tiaja. Until next week, as always, walk in health and peace.